Here we have examples of problems found in Chapter 1, Section 3, and they are about writing equations. Here we have two different forms of a linear equation. Y is equal to mx plus b, which is called the y-intercept form, and y minus y1 is equal to m parentheses x minus x1, and that's called the point-slope form. And they both are used for writing an equation of a straight line, and but each one has different things that you need. For example, the top one you need a slope and b, which is the y-intercept, to be able to complete an equation for that. And the bottom one, the point-slope form, it's called point-slope form because what you need is a slope and a point to completely fill it out. Okay, so what follows are just various examples of writing equations using given information. So in part A, or in the first example that I'm going to do, we have as given a slope and a y-intercept. And because we have a slope and y-intercept, I'm going to use the y-intercept form of an equation of a straight line. And so I simply just substitute for the m and for the b, and that is it. That's an equation that meets the requirements of the given information. That it has a slope of 2/3 and that it has a y-intercept of 1. Example B has different given information. It has a slope of 2/3 and a point -5, 1, which is x1, y1. And on this second example, I have a slope and a point, so I have the requirements for the second form that I have in the of an equation that I have up in the box, the point-slope form. So I'll use that other equation. So I go ahead and substitute for y1 and for x1 and for the slope, and that is it. Now sometimes, or actually a lot of times, they'll ask us to simplify that equation to put it in y-intercept form. That is to solve for y. And to do that, we simply modify that equation. What I like to do is I like to multiply by 3 both sides of the equal sign, and get 3y minus 3 on the left side, and on the right side, when I multiply the right side by 3, the 3's cancel out, leaving just the 2. So then I distribute the 2, and I get 2x plus 10. And from there, we just solve for y. We add 3 to both sides, and then we divide by 3. And we get our final equation of y is equal to 2/3, 2 over 3x plus 13 over 3. Okay, we continue. In the next example, the requirements are that the line goes through the point 2, -1, and that the line also has a slope of 3. And once again, in this particular example, I have a point and a slope, so I'm going to use the second form of the equation in the box, the point-slope form. So I have y minus y1, and y1 is -1, so y minus a -1 is the same thing as y plus 1, and then I distribute on the right side the 3, and then solve for y, and that is all. In the next example, the requirements are to write an equation of a line that goes through 2 points. Now, in this particular case, we don't have the slope. We have 2 points, but no slope. But what we can do is use the formula that we learned back in Algebra 1 for figuring out the slope. That is y2 minus y1 divided by x2 minus x1. So that's the first thing that I'm going to do. And here we get a slope of -1/6. Now, if I use that slope with one of the points, the coordinate points that I have in the given, such as the first coordinate point of 2, 1, and call that x1, y1, and use that point and then the slope of negative 1, 6, then I can use the second form of the linear equation, the point-slope form. And so I substitute my values in and solve for y. And I can do that like I did before. I can get rid of the fraction on the right hand side by multiplying by 6 both sides of the equal sign. On the left side I get 6y minus 6. On the right side, when I multiply by 6, the 6 on the denominator will cancel out with the 6 that I'm multiplying the right side by. So then I still have the negative 1, so I distribute negative 1 into the parentheses. I get negative x plus 2. And then, I just get the y by itself. I add 6 to both sides and then divide by 6. And I get the answer of y is equal to negative x over 6 plus 4/3. The slope in this case is negative 1, 6, and the y-intercept is 4/3. And that's done. Now the next example, I have a line and I wanted to go through these other 2 points, 2, 3, and the point 2, 7. Now I'm going to do it the same way as I did the previous example by finding the slope first using the slope formula. Now when I plug them in and I solve for the slope, I get no solution. I get 4 divided by 0, which is no solution. So that means that the slope doesn't exist. If I sketch what's going on, if I sketch the 2 points in the line that goes through it, I see that it's a vertical line. Now, vertical lines, the equations for all vertical lines are in the form of x equal a number. And in this case, that number is going to be the point on the x-axis that the line goes through. And that is the point positive 2 on the x-axis. So the equation is x equal 2, and that's it. And all vertical lines are going to be in that form, x equal a number. And once again, that number will be the one that that number on the x-axis that the line goes through. Okay, the next example, I'll want to find the equation of a line through the point 1, negative 3, and I want it to be perpendicular to this given equation of 3x minus 2y equal 4. Now to do this, I'll find the slope of the equation that I'm given there, 3x minus 2y equal 4. Now to find the slope, I'll solve for y. So I'll get that equation in the y-intercept form, and I do that by subtracting the 3x from both sides, and then dividing by negative 2, and I simply get that y is equal to 3/2x minus 2. Okay, so now I can figure out the slope of that equation, and that slope is 3/2. But when writing my equation, I'm not going to want to use 3/2. I'm going to want to use the perpendicular slope. And so we learned in this section that to find the perpendicular slope, it's a negative reciprocal. So I'll flip the 3/2 and get 2/3 and then change the sign. So I'll get negative 2/3 is the perpendicular slope, and that is the slope that I'm going to want to use to write my equation, my perpendicular equation. Okay, if it said parallel, I wouldn't do this. I would use the slope 3/2. But once again, the question says that it has a requirement that it's perpendicular. So I do the negative reciprocal. So now I have the slope that I'm going to use, and then I have the point of 1 comma negative 3, and then I'll use the point slope form to figure out the equation. And so I plug in the numbers, and once again I get rid of the fraction by multiplying by 3 both sides of the equal sign. And on the left side I get 3y plus 9. On the right side, the 3 on the bottom cancels out with the 3 that I'm multiplying by, and the negative 2 remains, and I distribute the negative 2. I get negative 2x plus 2 on the right side, and then subtract the 9 from both sides, and then divide by 3 as a final step, and I get y is equal to negative 2 thirds x minus 7 over 3. The slope is negative 2 over 3, and the y-intercept is negative 7 over 3. And that is it.